Hi everyone, I am Ashwant, student of SVCA Bangalore. Introduction to pointer aliasing. Pointer aliasing is a fundamental concept in low-level programming languages like C and C++. It occurs when multiple pointers reference the same memory location, allowing for different efficient data manipulation and access. Understanding pointers. Pointers defined. Pointers are variables that store memory addresses, allowing direct access to data in computer memory. They form a fundamental concept in programming, enabling dynamic memory management and complex data structures. Accessing memory locations. Pointers give programmers the ability to directly reference and manipulate data stored at specific memory locations, providing low-level control over a computer's memory. Pointer arithmetic. Pointers support arithmetic operations that allow you to navigate through memory, accessing adjacent data elements. This is essential for working with arrays, linked lists, and other dynamic data structures. Pointer arithmetic. Incrementing pointers. Pointers can be incremented to access the next memory location. This allows you to traverse arrays and other data structures. Pointers arithmetic. You can perform arithmetic operations like addition and subtraction on pointers to move them to different memory addresses. Pointers offsets. Pointers can be offset by a certain number of bytes to access specific elements within a data structure or array. Pointer dereferencing. Accessing data pointers dereferencing allows you to access the data stored at the memory location pointed to by a pointer variable. Indirect access. By dereferencing a pointer, you can indirectly access and manipulate the value at the memory address it's point to. Type safety. Dereferencing a pointers requires type matching to ensure the data is accessed correctly based on the pointer's declared type. Aliasing and memory locations. Pointer aliasing occurs when two or more pointers reference the same memory location. This can happen when a pointer is assigned the value of another pointer or when pointers are used to access the same data structure. Aliasing can have significant consequences for program behavior as changes made through one pointer may unexpectedly affect the value seen through another pointer. Consequences of pointer aliasing: memory corruption, undefined behavior, performance issues, and security vulnerabilities. In memory corruption, pointers aliasing can lead to unintended modifications of memory, causing data corruption and crashes. This happens when two pointers access the same memory location and one modifies the data unexpectedly. Undefined behavior. Accessing memory through an aliased pointer can result in undefined behavior, making the program's behavior unpredictable and difficult to debug. In performance issues, pointers aliasing can prevent the compiler from making important optimizations, leading to reduced performance. The compiler may have to make conservative assumptions to ensure correctness. Security vulnerabilities. Pointers aliasing can be exploited by attackers to bypass memory protection mechanisms and gain unauthorized access to sensitive data or executive malicious code. Avoiding pointers aliasing issues. Declare pointers carefully. Avoid using the same pointer for multiple purposes. Limit pointer scope. Use pointers only within the necessary block of code. And document pointers usage. Clearly explain the purpose and behavior of each pointer. To avoid pointer aliasing issues, it's important to be intentional and disciplined in how you declare and use pointers. Carefully consider the scope and purpose of each pointer and document their behavior to ensure they are being used correctly. Following these best practices can help you write more robust and error-free code. Best practice for pointer usage. Declare pointers carefully, handle errors, and optimize pointer usage. Always declare pointers with clear descriptive names to avoid confusion, allocate memory dynamically when needed to avoid dangling or null pointers. Handle errors. Check for null or invalid pointers before dereferencing them and gracefully handle memory allocations, failures, and other potential pointer related errors. Optimize pointer usage. Minimize pointer arithmetic and indirect access to improve performance when possible. Use references or smart pointers instead of raw pointers. Debugging pointer aliasing problems. Pointer aliasing can be challenging to debug as the issues may not be immediately apparent in the code. Careful analysis of memory usage, program flow, and compiler optimizations is often required to identify and resolve these problems. Debuggers, memory profilers, and static code analysis tools can be invaluable in uncovering pointer aliasing issues. These tools can help developers visualize memory layouts, track variable references, and detect potential conflicts. Conclusion and key takeaways. In this presentation, we have explored the critical concept of pointer aliasing and its amplifications in programming. By understanding the intricacies of pointers, memory management, and the potential pitfalls of aliasing, developers can write more robust and reliable code.